Hello again, and welcome to the third and last video on our Quizza 3D Studio Designer's Workflow. My name is Nuno Pinheiro, and I'm a designer at KDAP. We're starting where Kitsy left us off, and I'm going to show you where we were. As you can see, we have our cube using some Qt Quick controls. So the first thing we'll do is to theme those Qt controls. I'll do a fast iteration over that, but you can see that this gives us the freedom to style things as one sees fit. Here, I had that on an item, just made it visible now, and made the opacity of the cube control 0, so we don't see the original one, and we just see the styled version. Next step is to do what we're supposed to do, which is to create a more realistic reflection over the floor. To do so, the first thing that we do is to put our 3D scene inside an item that contains it. So we don't put so much effort into the Qt Quick graphical effects that we're going to use. Here, I'm just playing around, creating a rectangle to sort out things and show them where I want to see them. And here I'm trying to figure out the correct position and correct size. Seems like a good place. I'll just put my 3D scene inside of it, change the sizes, resort the position so it shows on the correct position again, and press play. Looking good. Everything seems in place. Now, just to be sure, I'll set the clip to true to see if I'm not clipping it. And indeed, I am clipping. This would be an issue when using the Qt graphical effects. And here I'm just displaying that indeed the clipping is on. So I'll just adjust very quickly the size of our container in order to not clip it. And as you can see, now it's not being clipped. Now, next. First thing that we're going to do is give an ID to the container. And finally, we're going to start doing our masking. The masking is done via a linear gradient that transforms the alpha level of the linear gradient into the alpha level of the result using an opacity mask. So here I'm doing that gradient, setting up the size. First it was big, then I made it as big as a container. Now I'm creating an opacity mask. The opacity mask is as big as the container. It has a source, which is the container again, and a mask source, which is, in our case, our opacity mask that we see there, be creating its ID. And the end result is something like that. Now, I might have overdone it. I mean that the reflection starts at the end of the first cube. So the opacity of the first cube must be full. Here I'm playing around with the positions of the gradient so that the first cube is fully visible. And in here, it seems like almost got it, but apparently in the end, there's something going on there and it's slightly transparent. I'll just make the visibility of my opacity mask visible again, figure out what's going on, and indeed, the opacity mask starts before the end of the first cube. I'll tweak that value there, the position of the start of the whiteness of the gradient, and indeed, it seems like I got a better value there. I'll just adjust a few other things so that the result ends up being a little bit better. Setting visible to false. And yes, it seems that it's better, yes, but maybe I can do it a little bit better. I'll make the beginning of the cube even more reflective, so more presence on the beginning of the reflected cube. I'm happy with this. And now we move on into the next step. A perfectly reflective background surface is kind of rare. That is reserved for glass and objects like this. In reality, reflections tend to be a little bit blurred, and the blurriness of that reflection increases as the distance between the reflection, and the object are from each other. So what I'm here creating is a gradient that is going to be used again with something similar to the opacity mask, but in this case, it's a blur mask. The result, what we want here is that the more that the mask is visible, the bigger the opacity of it, the more the blur is going to occur in that area, that pixels. How do we do that? You see me here doing a linear gradient. I was adjusting it, and I was applying to a border, a opacity, a blur mask, as I was saying. Now, the problem there was that the radius was too small and I couldn't see anything. Increase the radius of the blurring, and maybe in this case, I overdid it. Going a little bit for the middle result, I'll just specify a radius of 15, press play, and I think we are good to go. As you see, it's rather simple to integrate 3D assets into your QML application using the Queza 3D Studio workflow. The iron materials are incredibly performant, allowing you to achieve visual results on hardware that otherwise would not be able to, like the usual 3D hardware seen on the embedded space. Also, hopefully, you got to see the ease of use of the GLTF to QML export features in Studio. Those do not require an explicit import step in the QML side, allowing for easy changes in the 3D model even after the application implementation. This results in a faster turnaround when designing and adjusting the 3D elements. Note that Queza also has support for multiple 3D editing applications such as Maya, 3D Studio Max, and Blender. Queza does not force you to have to learn a new tool, or at least we try to. But the main message that we wanted to pass on this series was that your creative freedom as a designer is not hampered by this workflow, and in fact can even expand your creative toolbox. At the end of the day, it's, in my opinion, a fun, creative way for you to express a user experience. This was just a simple example, and the Quiz plus Iron Materials plus QML can actually produce a wide range of modern UIs with compelling user experience. If you are interested in more little videos like this, please let us know in the comment section. Hope you enjoyed, and remember, always have fun.